In 1946, American locomotive builders controlled 98% of Mexico's railway equipment market. Baldwin, ALCO, Lima, their names appeared on every major locomotive roster south of the border. Mexican railway officials traveled to Philadelphia and Schenectady like pilgrims, checkbooks ready, because everyone knew a simple truth. Real locomotives came from the United States. Then Mexico built one that outperformed them all. And for decades, the companies that lost the contract pretended it never happened. The locomotive was the QR1, and its story begins not with steel and steam, but with economics and pride. By the mid-1940s, Mexico had spent millions importing American locomotives that struggled in conditions their designers had never encountered. And the grades climbing out of Veracruz toward Mexico City reached 4% in places, brutal pitches where Northern Pacifics and Mikados gasped for breath in the thin air above 7,000 feet. Boilers designed for Pennsylvania coal burned Mexican fuel oil poorly. Maintenance manuals assumed parts and expertise that Mexican shops lacked. But the real problem was cost. Every locomotive drained dollars from Mexico's treasury. Every replacement part, every technical consultation, every training session in Schenectady, dollars flowing north while Mexican engineers watched, learned, and quietly seethed. In 1945, the Ferrocarriles Nacionales de Mexico issued an unusual directive to its mechanical department in Aguascalientes: design a locomotive, not modify an American design, not assemble American components. Design one from scratch, being built entirely in Mexico for Mexican conditions. The chief mechanical engineer, Valentin Lopez, had spent 20 years maintaining American locomotives. He knew their strengths. He also knew their fatal assumptions. American builders designed for abundant coal, flat terrain, sea-level air density, and unlimited spare parts. Mexico needed the opposite: efficient oil burning, steep grade capability, high altitude performance, and complete independence from foreign supply chains. Lopez assembled a team of Mexican engineers who had learned their trade the hard way, fixing what broke, improvising what was unavailable, understanding through necessity what American designers knew from textbooks. They started with a clean sheet of paper and one requirement: beat American locomotives at their own game on Mexican rails. Near the specifications emerged over months of calculation: a 4/8 four-wheel arrangement for the power needed on steep grades, but with weight distribution optimized for Mexico's lighter rail; a boiler designed specifically for Mexican fuel oil, with combustion characteristics tuned to local petroleum rather than Appalachian coal; valve gear that could be manufactured and maintained with Mexican machine tools; bearings that tolerated Mexican dust and heat. Most radical was the decision about altitude compensation. American locomotives lost roughly 3% of their power for every 1,000 feet of elevation. Mexico City sat at 7,500 feet. The QR1's designers couldn't change physics, but they could change assumptions. Instead of building a sea-level locomotive and accepting its high-altitude weakness, and they designed for performance at 7,000 feet and accepted that it would be overpowered at lower elevations. The prototype emerged from Aguascalientes shops in October 1946. Number QR1, painted in FNM green with red running boards, weighed 362,000 pounds. Its 73-inch drivers promised speed. Its 28,000 pounds of tractive effort promised power. but numbers on paper meant nothing until steel turned on steel. The test runs began in November on the Mexico City to Querétaro line, a route American builders knew well, having supplied dozens of locomotives for it over the decades. FNM invited representatives from Baldwin, ALCO, and Lima to observe. A gesture of courtesy, everyone assumed. Mexico showing off its little achievement before ordering more real locomotives. In the QR1, hauled 1,100 tons up the grade out of Mexico City, maintaining 42 miles per hour at altitudes where American Northern struggled to manage 35 with 900 tons. Fuel consumption ran 18% lower than comparable American designs. The boiler maintained pressure effortlessly at 7,000 feet, exactly as Lopez had calculated. The American observers took notes politely. Then they went home and wrote reports that never mentioned Mexican engineering capability. The QR1's performance was attributed to favorable test conditions and light loading. One internal Baldwin memo suggested the Mexican figures were optimistic without evidence. FNM ordered 29 more QR1s, all built in Aguascalientes, all delivered between 1947 and 1949, odds all outperforming their American counterparts on steep grades and high-altitude runs. Mexican crews praised them. Operating costs dropped. Maintenance schedules stretched longer because parts weren't waiting on shipments from Pennsylvania. American locomotive builders took out advertisements in Mexican trade journals, showcasing their latest models. Not one mentioned the QR1. Industry publications in the United States discussed Mexican railway modernization without acknowledging that Mexico was building its own modern locomotives. When Baldwin salesmen visited FNM headquarters in 1948, their presentations compared Baldwin products against other Baldwin products, as if the 30 QR1s running daily service didn't exist. The silence was strategic, admitting that Mexican engineers had designed a superior locomotive for Mexican conditions would undermine the fundamental sales pitch that advanced engineering happened in Philadelphia, Schenectady, and Lima, not Aguascalientes. If Mexico could build locomotives, what else might they build? What other markets might question whether American manufacturers truly understood their needs? The QR1s ran for decades. They hauled freight over the mountains, pulled passenger trains through the high desert, proved themselves in service that American locomotives found punishing. FNM engineers documented their performance meticulously. Availability rates, fuel efficiency, maintenance costs. The data was overwhelming. Mexican-designed locomotives, built with Mexican labor and materials, matched or exceeded American imports. But the American industry kept selling as if nothing had changed. Catalogs from the 1950s presented American locomotives as the only serious option for modern railways. Trade show displays at international exhibitions featured Baldwin and ALCO prominently. The QR1 appeared in no manufacturer's competitive analysis, no engineering journal comparison, no industry retrospective. The erasure was nearly complete until Mexican railway historians began documenting their own heritage in the 1980s. They found the test reports, the performance data, the maintenance records. They interviewed retired crews who remembered the QR1s fondly, engineers who had built them with pride, mechanics who praised their reliability. A locomotive class that had run for 40 years, proven its worth thousands of times over, and been systematically ignored by the industry that couldn't match it. Today, one QR1 survives in the National Railway Museum in Puebla. It sits next to imported American locomotives from the same era, machines that cost more, performed worse, and dominated the history books. The plaque beside it tells the technical story, specifications, service history, retirement date, but it doesn't capture the larger truth about what the QR1 represented. Mexico proved that locomotive engineering wasn't a uniquely American skill, that local knowledge mattered more than foreign prestige, that the assumptions built into American designs weren't universal truths. The QR1 was more than a successful locomotive. It was evidence that the industrial hierarchy everyone accepted, American builders at the top, yet everyone else as customers, was neither natural nor inevitable. American companies refused to admit the QR1 existed because acknowledging it would mean acknowledging something more threatening, that their dominance depended not on superior engineering, but on assumptions, inertia, and the power to control which achievements entered the record and which vanished into silence. The QR1s are gone from the rails now, but their test reports remain, filed in archives that tell a different story than the one American builders wanted told. Numbers don't forget. Data doesn't care about marketing, and sometimes what industry leaders refuse to admit becomes precisely what history needs to remember. 30 Mexican-built locomotives that worked better than imports, decades of superior performance, and an industry that looked the other way rather than admit that engineering excellence could emerge from anywhere, designed by anyone, built by people who understood their problems better than foreign experts ever could. The question isn't why American companies refuse to admit the QR1 existed. The question is, what else are we still refusing to see?